For those who are online, are you able to hear me?
Yes, sir.
Yes, sir.
So yesterday, what was the last concept we were discussing? This part, no? Right. So within the elastic limit, we saw that modulus of elasticity is defined as the ratio of the resistance to spin. Okay. Now, the next concept that we are supposed to see is Young's modulus of elasticity. Did we see this concept? All right, yesterday I told you, right? So within elastic limit, if you're able to calculate the ratio of longitudinal stress to the longitudinal strain, it is called as Young's modulus of the material of the wire. Right? See, you have a figure here. When there is a wire that is suspended, and that wire, which is there is another weight which is suspended to the other end of the wire. Okay, so there is a wire that is suspended from the ceiling, and there is another other load which is connected on the other end, so that the load is applying the force in the downward direction. So what will happen to the wires? It will get elongated by a value of delta L, and let's say the area is A. So if that is going to be the case, then what is going to be the Young's modulus associated? So Young's modulus within the elastic limit, if I call it as Y, what is it going to be? It is going to be longitudinal stress divided by so what is longitudinal stress? F divided by A divided by what is the longitudinal strain? So it is going to be F into L divided by A into delta. So this is going to be the formula for Young's modulus. Done? Can I proceed? Okay. The next important concept is, so mark it as important. It is stress strain curve for a metallic wire. Stress strain curve for a metallic wire. So now the question is, if I have a metallic wire, at the other end, if I suspend a load and I keep increasing the value of it, how is the relation between stress and strain going to change? So we know that stress is directly proportional to strain only to the certain limit. What is it called as? Elastic. Beyond that, we are interested to know what will happen to this particular material, right? So when I talk about the stress strain curve of a metallic wire, this is how the graph will look like. Okay, this graph, how many points do you have? You have points A, B, C, E, and you have a point E as well, right? Now we are going to see what these points are actually going to represent. We'll see them one by one. First is, I have the graph again. Okay. So in this graph, the first point to be noted is stress is taken on the y-axis and strain is taken on the x-axis. Okay. And what is the name of this curve? It's called stress hyphen strain curve. So first thing, the initial part OA of the graph, right? So what is the initial part OA of the graph representing? It is indicating that it is a straight line, right? Straight line where it is clearly telling us that stress is directly proportional to strain, or I can say stress is equal to E times strain, where that E stands for modulus of elasticity, right? Now, if I take stress on y-axis, right, is it not looking in the form y is equal to mx? I'm not sure if you have learned straight lines. Did you? So y is equal to mx is a straight line passing through origin, right? So y is equal to mx is a straight line passing through the origin. And if you see, the graph is not exactly going to make 45 degrees. It is more inclined towards the stress. Is that clear? So you should not exactly draw it at 45. So the graph is inclined towards stress till which point? Till a point called as elastic movement. Okay. Now the question is, after the point A, so before that, let me tell you, the initial part OA of the graph is a straight line indicating that the stress is directly proportional to the strain. Up to point A, Hooke's law is obeyed. So the point A is called as the proportional point or proportional limit, right? So in this region, what can you say in the region OA, that this material, the metallic wire that you're taking into consideration, is going to be a perfectly elastic object. Because what is the meaning of it? Means between OA, you release it anywhere. If you take out the deforming force, the object will come back to its original shape and size. That is why it is considered to be perfectly elastic in that region. Okay, next the question is, what happens after it crosses point A? So after the point A, the stress is not proportional to the strain. What is happening? The stress is not proportional to the strain and it starts bending, right? And a curve AB is obtained. However, if the load is removed at any point between O and B, the curve is retraced along the path BA. What is going to happen? Though you are going to slightly increase the load beyond the proportional limit, you can see that the curve is no more going to be a straight line. So when it is no more a straight line, what is it trying to mathematically indicate us? It is trying to say that stress is not anymore proportional to the strain. So when they are proportional, what should have happened? It should always be a straight line. So if you observe this, the graph is not stress strain, or I can put it like this, not a straight line saying the stress strain curve. It says stress strain curve. So there is a curvature that is going to take place after certain points. What are those points? The first point is after the proportional limit. Are you able to think of it? Are you able to visualize it? So beyond the proportional limit, if you try to elongate it, when it goes to another point P, though the graph is not going to be a straight line, but still, if you remove the load, at which point anywhere between O and P, the curve will retrace the path. Okay, so that is what they're saying. The curve is retraced along BAO and the wire attains its original length, but I cannot say it is perfectly elastic because it's not obeying the Hooke's, right? So attains its original length. The portion OB of the graph is called as the elastic region. Then what is the point B called as? It's called as the elastic limit or yield point. What is a point B called as? It's called as elastic limit or yield point. Why is it called as elastic limit? Because the curve is getting retraced along the same path in which it got carried forward. Right? So the stress corresponding to the yield point. So stress is on the y-axis. The stress corresponding to the yield point, if I take this point, is called as what? Is called as the yield strength. The stress corresponding to the yield point is called as the yield strength. Right? So up to point B, the elastic forces of the materials are conservative. That is, when the material returns to its original size, the work done in producing the deformation is completely recovered. So what do you mean by conservative here? It means that the energy is still conserved. Means whatever energy I put in to get that work done, you will be able to get it done. That's the thing. Am I clear with these 2 points? So don't sit and write everything. Okay. So in the class, I want you to have a practice of taking short notes. So in this graph, what are the important points I mentioned? I'm trying to concentrate on points. So write the heading as stress strain curve for a metallic wire in that. What is point A called as? It's called proportional limit. So take down those points alone. Once I send you the PPT, you can take. So that we can save time and taking notes. So yeah, we'll concentrate on problems. So A is called as the proportional limit. This is directly proportional. This curve will be a very small. Your rubber band, have you ever tried to play with it? If you take a rubber band, try to pull it to a certain limit and leave it, it's going to be fine. If you pull it beyond a certain point, you will be able to observe that white color thing that's coming. So those things will change. And the white color, if you release it, you will not be able to come back to a certain point. If that white layer becomes very thin, after a point it will break. Means it will become a brittle material. It's no more an elastic. So the curve fracture point, what is the plastic point and all those things. So this part AB is not going to be a very big push. It's only a certain limit. And moreover, in the material, this curve is applicable only for whom? What is the heading you wrote? Stress strain curve for a metallic wire. I'm talking about a metallic wire. Here. And moreover, can someone tell me why do we read this chapter? Is an idea of everybody. Apart from scoring marks, all that nonsense. Why are you studying this? I'll come to that. So think it. Why do you think it is going to be applicable? Metallic wire எப்படி இருந்தா ஆக்கணும். Why are you studying? Perfect. So you have for civil engineering and all, you need to know the strength of the material for doing. Right. You cannot just like that use anything. See, bricks undergoes a lot of testing process. Suppose let's say there is a construction thing for which you need raw materials. You're in one of the departments. Say you're the head of the department and you need to do a testing or something. You need to know these concepts. So bricks, see, I'll ask you a simple question. I'll give you a brick and I'll ask you to find whether it is hollow inside or is it completed with what would you do? Simple logic and break it up. How many bricks? You will break all the bricks, right? Then why are you making it? You will sell what those pieces of bricks, that red color particles to people. What will you do? See, simple na கேக்குறேன். படத்துல கூட பார்த்திருப்பீங்க. ராட்சசன் படம் பாத்தீங்க. Okay, good enjoy. You watched? Okay. ராட்சசன். பாத்தீங்களா? அதுல how does he find that killer? You didn't see it?
Sir, no. By hitting and listening to that sound, it makes some sound.
It steps on a particular place, it will be here in a different way. So what we have? It's not. So brick enna panni paakram. It's basically 9th standard science. Sound and padisingalla. You're touching the wrong point which you're not supposed to touch. Okay. That against this deleted portion. So what will you do? If something is hollow, what will you do? Just tap and see. Based on the sound, you can decide whether it is going to be hollow or. In a similar way, you have certain strengths to be measured, right? You need a load to be measured. See, load under there are different kinds of load. I'm just giving you an outline. out of context. For example, in here, what are we using as a load? Or metallic wire, you are suspending something and right? So you're in electrical engineering, which, for example, this fan is there. Can I call this fan as a load? We have learned electricity chapter, right? So the bulb is a load. We are load and so. But it's a load because it's used to see some output. It is helping us to understand certain factors. So what can you say? For example, why am I calling it as load? This one the regulator, the filer. I switched on the fan. If it is running slowly compared to the previous one, what can you say? Fan is default, but fan is shop line wind on the shop light work perfectly fine. You know that fan is not default to use. It's a low voltage. It speaks something about the voltage. That's a testing process. So it is helping you to understand other parameters. That's the curve. If you break down everything, right, it's a very small point. Material on I'm saying, talk about the elastic property of that material to me. How will you do it? For load, you'll ask me, sir, you give me wire, you give me a load and one fixed point. Now load a connect panita, I'll try to pull it to different points and I'll measure and give you the curve. Otherwise, decide whether this material can be used in the construction site or not. How things are getting related. So you're learning the basics of it. So if you go into civil engineering or something, you need these basics. Sound also they deleted in 9th sector. Shameless creatures. Sound waves. You learn about it. 15th chapter waves. It's interesting at the same time slightly complicated. Maths. That's trigonometry ready. Sin C plus sin D, sin A plus B, ready. And trigonometric equations second get a sin theta is equal to sin alpha. Theta. That's a particular solution, general solution also. N pi, hello. I asked you a question. Sin theta is equal to sin alpha. Theta is equal to what? I'll give you that. General solution on the Need it, go and read it. Okay. N pi plus of minus 1 to the power n into alpha on the particular. Waves. Waves only Doppler effect is related. First one deleted for the life of you. Oh, who is sitting and deleting all this? I don't know why they deleted completing the square for instant. Quadratic equation formula, I don't know how to. Okay, listen. So in the curve, now we saw about 2 points. Those are online. Am I clear, guys? Are you able to understand?
Yes, sir. Yes, sir.
Yes, sir.
Very good. Shall I proceed? Okay.
Okay, sir.
Beyond point B, the strain increases more rapidly than stress. Listen to this point, okay? The graph out there. When I give you the statement, how will you draw the graph? When I say strain increases more rapidly compared to stress. That is, X increases rapidly compared to Y. So where should the graph be confined to? X. That is the meaning. So that is why if you see the graph is bending more towards X axis. Between the points O to A, stress was dominating the strain. From A to B, there was a certain increase till the yield point. After this, what is happening? If you go beyond point B, the strain increases more rapidly than stress. So if the load is removed at any point C, the wire does not come back to its original length, but will retrace the path CE. Means if this is the original length with which you started, if we take as a reference point, you can never get back its original point because the strain has increased. What is the meaning of strain? Strain is responsible for the change in dimension. So dimension of markers. So that material's property is disturbed. Now what will happen? You cannot get back its original length. That's the meaning. So wire does not come back to its original length, but traces the dashed line CE. So even on reducing the stress to zero means if you completely remove the load also, there is a strain that is going to exist in the material called as residual strain. If I have to give you an example of this, have you ever played with a magnet and a scissor? Like if you take a magnet, if you take a scissor, right? If you take that magnet and rub that scissor, okay, let's say you do it for 1 minute. After that time, you remove the magnet, take that scissor to a magnetic substance. Will that scissor be able to attract it? So that is called as residual magnetism. Residual magnetism. Where is it acquired? It has acquired from some other magnet. In a similar way, this is called as residual strain. Why is it residual strain? Because it is existing. Some residues are existing. So that is why the name is given as residual strain equal to OE left in the wire. Okay. So the material in this situation, what you can say is the material has acquired a permanent set. Meaning, that's got reshaped. That's the meaning of permanent set. Correct? So the fact that the stress strain curve is not retraced on reversing the strain, coming back in the same path is what is called as elastic hysteresis. Hysteresis is lagging. It's called lagging. Something is lagging behind. So the logic which I'm telling you now, listen to this very carefully. A similar kind of a graph we'll learn next year in a chapter called magnetism and its magnetism. Another use the word magnetism. So on the time you will see the word hysteresis. It should not be a completely new term. On the time we call it as hysteresis loss. Indian we call it as elastic hysteresis. So the hysteresis is a concept when it comes to picture, when there is some residue left out after the loads are removed. So whenever you remove a load, what is it you expect? You expect the original shape. But what is happening? Unfortunately, the original shape is lost. There is a permanent set. And that distance we call it as residual. Now, if the load is increased, so you have already created a permanent set in the material. Now, what are you doing? You're not letting the material relax. You're again increasing the load. Right? You're increasing it till, or let's say you're increasing the load beyond the point C. There is a large increase in the strain or the length of the wire. So what is happening? As soon as you start increasing, what will happen is strain will become more. How do I make you feel? See, for example, you take a clay. Okay, you will think on a clay at the bunch. You keep pulling it. What will happen? It becomes thin after a certain point. Because what is there? Whatever volume of clay you have taken is getting readjusted. So when you pull it, it keeps becoming thin. After a certain point, you keep pulling it, it becomes even more thin. Means it is becoming more vulnerable. What is the meaning of vulnerable? Means even if I apply less load, it starts expanding rapidly. The same thing is happening. So initially the material had elastic property due to which the restoration force inside the material was fighting to get back the material to its original shape. But what is happening? After the point C, what did you do? You created a permanent set. Means the material has got weak. Accepted. Now it has lost its elastic property, no doubt in that. Means it is attaining towards, or it is traveling towards plasticity. Means that material is going to be more easily attacked by external forces. So you increase the load beyond point C. That is what they're saying. In this region, so there is a large increase in the strain. Okay, there is a large increase in the strain for the length of the wire. So even for lesser load, you can have more elongation because it has become weak. In this region, the constrictions no longer, we call it as necks and waists. We don't generally use this word. Okay. So develop at few points along the length of the wire, and wire ultimately breaks at point B. So what is going to happen is the strain is going to increase after point C, and if you keep increasing the load even to a slighter extent, there will be a point after which the material will break down. It will become two pieces. So at that point, we call it as a fracture point. Are you able to visualize this? Right? So in this region B to D, what is happening? The length of the wire goes on increasing even without any addition of load. You're not adding much. Even if you add slighter value, it keeps increasing. And this region is called as the plastic region, and the material is sent to undergo plastic flow or plastic deformation. And the stress corresponding to the breaking point is called as the ultimate strength or the tensile strength of the material. So from here, if I draw a perpendicular, then this point is called as, what do you call this point as? The stress corresponding to the fracture point is called as the ultimate strength or tensile strength. Beyond that, what is going to happen? Material illa. So you have no testing to do. It's broken already. So ultimate is maximum. Purida. So it's actually simple words only which you need to B2, C2. Actually, B2D B2D this point is also creating more stress for lesser strain. Okay. So let's come from the beginning. What is point A called as? Proportional limit. What is point B called as? Elastic limit or yield point. So at point C, what will happen if you release the material? There will be some residual strain set in the material, due to which there will be a permanent set in the shape. After point E, what will happen? The strain will increase at a rapid rate even for a lesser value of load, means it is attaining a region of plasticity, and at point D, which is called as the fracture point, it breaks. So what is the stress corresponding to the fracture point called as? It's called as the ultimate strength or tensile strength of the material. Am I clear? Often this question is asked for 3 marks, where you will be asked to draw the stress strain graph and explain each point. Will you be able to do it? Not much derivations in this. All the definitions. There is only one derivation which will create potential. Shall I proceed? See, only till point B, the point B, my elastic property is found. That is why B to D is called as the plastic region. Shall I proceed? Straight with the procedure. So let's do some problems that are based on Young's modulus. By the way, those who are online, are you all clear?
Yes, sir.
Yes, sir.
Perfect. Okay. So let's do some problems that are based on Young's modulus. Make it faster. Lagging. History is just lagging. One parameter is lagging compared to another. So in history resist, the prefix that you need to add is called as elastic. History resist magnetism compared. Shall I proceed now? So let's see the formula that we need to use. One is stress, which is force by area. Longitudinal strain, which is the change in length divided by original length. Young's modulus is within the elastic limit longitudinal stress by longitudinal strain, which is going to be F by A divided by delta L by L. So F by A into L divided by delta L. So percentage increase in length is delta L by L into. So this is also another question that they've asked. So delta L by L is called as the fractional change. Mostly when you talk about the wire, it undergoes only tensile stress, not the compressional stress. Right? So fractional change means here I'm talking about fractional increase. So delta L by L into 100 and other, it's called percentage change. So what I can do with this, if y is equal to F by A into L divided by delta L. So what I'll do is I'll rearrange the equation. Delta L by L will be equal to how much? F divided by A into y. So if you multiply with 100 on both the sides, I get the percentage change or increasing. It's not a formula or something. This is rearranging the equation. So the thing that you need to remember is Young's modulus. If you remember that, you can rearrange anything. Am I clear? Shall I proceed?
Yes, sir.
So the length of a suspended wire increases by 10 power minus 4 to its original length. So there is a wire suspended. Okay, its length increases by 10 power minus 4 to its original length when the stress of 10 power 7 Newton per meter square is applied on it. Calculate the Young's modulus of this material. So y is equal to how much? F by A divided by delta L by L. But so F by A is already given, that is this. So F by A itself is directly given, no, 10 power 7 divided by delta L by L. Another, read the question carefully. Increases by, not increases to. Increases by and put that to the change. So 10 power minus 4 divided by, sorry, delta L by L itself is 10 power minus 4. Read the question. Increases by 10 power minus 4 to its original length. Upper delta L another 10 power minus 4 to its original length into L. So delta L by L will be how much? 10 power minus 4. So if you put 10 power minus 4 here, answer will be 10 power 11 Newton per meter square. Simple problem. No? 10 power 11 Newton per meter square. Right. Next. Second, there is a wire which is made up of steel and it is of length 2.5 meter and density of 8 gram per centimeter cube. It weighs 50 gram. When stretched by a force of 10 kilogram force, right, the length increases by 2 millimeter. Calculate the Young's modulus of the steel. So take the data properly. Length 2.5 meter. Density is, so 8 gram per centimeter cube, right, is how many kilogram per meter cube? It is 8,000 kilogram per meter. Because 1 gram per cc is 1,000 kilogram per meter. Okay. And mass is how much? 50 grams. So 50 into 10 power minus 3 kilograms. When stretched by a force of 10 kgf, so kilogram force. So what should I do? 10 into multiplied with 9.8 to convert it to Newton. Okay. So the length increases by 2 millimeter. Delta L is 2 millimeter or 2 into 10 power minus 3 meter. Calculate the Young's modulus. So Young's modulus is equal to F by A divided by delta F by F. So why did they give you the density and the mass? So if I take the wire like this, right? This area multiplied with length will give me base area multiplied with thickness is volume. Correct? Huh? So density is equal to mass into volume. Huh? Mass volume. Sorry, mass by volume. So mass divided by volume, can I write it as A into L? This is rho. So what can I say? A is equal to M divided by rho into L. Which area is that? It is the cross-sectional area. It's not the surface area, it is the cross-sectional area. So do you know all the parameters? Substitute, calculate the value. So force is 10 into 9.8 into L is how much? 2.5, which is 5 by 2 divided by 2. A is mass of 50 into 10 power minus 3 divided by rho into L. So 8 into 10 power 3 into L is again 5 by 2 into delta L. So delta L is 2 into 10 power minus. Hello. 2.5. Tell me the approximate. Bit 5 and 5 or 4.9. Okay, so calculation you note later, you get 5 into something. 4.9 into 10 power 11. That is in 9 per centimeter square, but I converted everything to SI unit. No? About 10 power minus 5 or 10 power 6 or about. Because I converted everything to SI. They have solved it in SCGS. Another they got in 9 per centimeter square. You will get it in Newton per meter square. Check that if it is a Newton per meter square, you should get 10 power 5, 10 power 6. So that part I'm leaving it to you. Okay. So we'll go to the next concept. Listen. The next concept is bulk modulus of elasticity. This also I gave you the introduction yesterday, right? So what are the corresponding strains and stress to which this is related to? Within the elastic limit, the ratio of hydrostatic stress to the volumetric strain. It's called as the bulk modulus. See, hydrostatic stress, they also call it as normal stress at some point, because when we discuss hydrostatic stress, what did they say? It is perpendicular to the surface at every point. So that's why they call it as normal stress also. So, but the major point to be noted here is within elastic limit, if the ratio of hydrostatic stress to the volumetric strain is able to be defined, it is called as the bulk modulus of elasticity. Okay. So if you consider an object of volume V and surface area A, suppose a force F acts uniformly over the whole surface of the body, and the volume decreases, and the volume decreases by A into V. It's not A V, it is delta V. And the volume decreases by delta V, then the bulk modulus of elasticity is given as normal stress divided by the volumetric strain. But remember one thing, whenever you apply a hydrostatic stress, the object will always undergo compression. So when it is going to be compression, what is going to be the value of delta V? It will be negative. So that's why the bulk modulus can be written as F by A, the applied hydrostatic stress, divided by the negative of delta V by V. Okay. So this F by A is also called as pressure. So P into V divided by negative of delta V. Remember this parameter, this is very important. I told you about waves chapter, no? Same waves chapter, this is. Remember this definition. The units is again the same as that of stress. So the SI unit of bulk modulus will be Newton per meter square or Pascal. Here I am using Pascal because it is mostly used for fluids. And what is going to be the CGS unit? It will be dyne per centimeter square. Am I clear, guys? And here, when I talk about the pressure you're trying to talk about is only the normal pressure. Clear? Okay. Now we are able to understand that when you apply a hydrostatic stress, right, what is happening to the object? It is getting compressed. So we need to see another term called as compressibility. Okay. So we'll see another term called as compressibility. So it states something like this: the reciprocal of bulk modulus. What is it? If you take the reciprocal of bulk modulus, it speaks about a term called as compressibility. That's it. Simplest definition. Reciprocal of bulk modulus is compressibility. What is going to be the SI unit of it? Newton inverse meter square. And what is going to be the CGS unit? It will be dyne inverse centimeter square. And what is going to be the dimensional formula? M minus 1 L T minus 2. And there it was T power minus 2. No? They get reversed. Here. Shall I proceed? So example, we'll see. The pressure of a medium is changed from 1.10 into 10 power 5 Pascal to 1.165 into 10 power 5 Pascal. And and change in volume is 10%, keeping the temperature constant. They use the word temperature constant because they are trying to speak about a condition called as isothermal condition. You know what is isothermal, right? Iso means same, thermal is temperature. Okay. So the pressure of a medium is changed from 1.01 into 10 power 5 Pascal to 1.165 into 10 power 5 Pascal, and the change in volume is 10%, keeping the temperature constant. Find the bulk modulus of the medium. Simple. What is it going to be? P divided by negative of delta V by V. So change is 10%. So what will be the fractional change? 10%. 10% is 100. Cancel these two. It is 0.1. Right? So P is how much? 0.154 into 10 power 5 divided by 0.1. Otherwise, 10 power minus 1. So 0.154 into 10 power 6. Mistake here, 10 power 6. 10 power 5 because it will be 1.54 into 10 power 5. That is going to be the bulk modulus. Oh. 0.155. Okay. So correct 0.15. So 1.55 into 10 power 5 Pascal. I subtracted 1 from 65. I can see this one. So 1.55 into 10 power 5 Pascal. Puriyada? Change in volume. The change in volume is 10%. How much more? 165 minus. Correct then? So 1.55 into 10 power 5 Pascal. Clear? Shall I proceed? Yeah. So modulus of rigidity or shear modulus. So how do we define it? It is defined as ratio of, you want to copy it? Okay. So how is it defined? It is defined as a ratio of, within the elastic limit, the ratio of the tangential stress to the shear strain. This I showed you yesterday. If I take this to be theta and everything I showed you now. So what is going to be the stress? Tan theta. So tan theta would be delta L by or delta X by L. Right. So it will be F divided by A divided by delta L by L. Or it is going to be F into L divided by B into delta. See, simple as well, right? It is going to be F divided by A by theta, where theta is measured in radian. The value of theta is supposed to be small. Clear with this? So those who are online, is it clear?
Yes, sir.
Shall I proceed? You know, that doubt. Parallel. It's called parallel of light. It's a three-dimensional parallelogram. Cuboid இருக்கா? Cuboid வந்து when you compress it இது இருக்கா? இது cuboid. When you do it like this, it's called as a parallelogram. 3D parallelogram. சொல்லக்கூடாது புரியறதுக்காக thing is, and the top surface and bottom surface will be at a certain distance. They will not be inclined to each other at 90 degrees. But மத்த surface லாம் பார்த்தா it will be at 90 degrees. So இதுக்கும் they both are parallel. இதுவும் parallel. அதே மாதிரி இந்த side and the side will be parallel. But this side and this side will not be parallel. You will be learning about it next year. Max. They'll be parallel. They'll be parallel, but they will not be perpendicular to the basis. Correct question. So let us solve a problem. There is a cube of aluminum of each side 4 centimeters is subjected to a tangential shearing force. The top face of the cube is sheared through 0.012 centimeter with respect to the bottom face. So what is the meaning of this? The relative displacements between the two parallel surfaces is going to be 0.012 centimeter. Find the shearing strength. Will you be able to find it? So what is the shearing strength? 0.012 divided by the relative displacement between them. So what is the displacement between the top and the bottom surface of a cube? 4. So are they both in centimeter? Yes, they are. So answer will be 0.003 and will be in terms of radian. Clear? புரியுதா நான் சொல்றது? It will be 0.003 radian. Next is find the shearing stress and shearing force. They both are different. What is going to be the shearing stress? It will be F divided by A. So what is F? So F divided by A is not known to us. So they are given the value of modulus of rigidity. So modulus of rigidity is how much? Stress divided by strain. So this value is given 2.08 into 10 power 11 into strain is how much? 0.003 is equal to stress. Can I write it like this? So 2.08 into 3 is how much? 24 to 6.24. So 6.24 into 10 power 11, this will be minus 3. So 10 power 8. So 10 power 8, 9 per centimeter square because everything is in terms of SI. You understood what I did? I wrote the 0.03 as 3 into 10 power minus 3. So 2.08 into 3 is going to be 6.24 into 10 power 11 into 10 power minus 3 is 10 power 8. Purida. Next is find the shearing force. How to calculate it? So F by A is equal to 6.24 into 10 power 8. But if they give us the area, we can still find it because it's a cube. So the force applied on the top surface of the cube, the top surface area is going to be 4 square. It's a square. So F will be equal to 6.24 into 10 power 8 into 4 square is going to be 16. So multiply everything, that will be the answer. How much? See. Listen, whenever you want to do calculation, you see. 624 into 16 written. Now you can write this as 624 into 10 plus 6. Okay, the decimal will deal it later. So it is going to be 6240 plus 624 into 6. 4 6 is 24. Here 2 will come. 12, 4, 1. 6 into 6, 37. So you are going to get 3744. Answer in our 4, 8, 9, 9. So 9984 la put 2 decimals to the left. So 99.84 into 10 power 8. Or 9.984 into 10 power 9. What is this property called as? So it's the distributive property. Okay. So make your calculations faster. Okay. So is it clear? Those who are online, is it clear? Those who are online, is it clear?
Yes, sir.
So the last topic of this chapter. So elastic potential energy of a stretched. Okay, write it. So there are 3 things we are going to see in this topic. One is we will see what is elastic potential energy in the first place. Second is we will derive an expression for the elastic potential energy of the stretched wire. And the third is we will find the energy density of the seam. You know what is energy density? See, most of the terms will give you the hint. Energy density. Na? See, what is mass density? Mass per unit length, na, linear mass density. Mass per unit area, na, areal mass density. Mass per unit volume, na, volume mass density. Energy density, na, what kind of a shape you are dealing with? Wire 3-dimensional, 2-dimensional, 1-dimensional. 3-dimensional. 3-dimensional can define what? Length, area, or volume? Volume. But energy by volume will be the energy. Depending on the shape, you need to define. If I have to speak about the energy density with respect to a square, what will I call it as? Energy per unit. We have to. Okay. So first we will see what is an elastic potential energy. When a wire is stretched, right? Its interatomic forces come into play, which oppose the change. That's what the restoring forces. So what are we supposed to do when you're applying this external force? We need to do some work against whom? When will you speak about energy, guys? When are you going to spend your energy? When you need to do some work. So when you're doing some work, you need to do some work against something. Here you're doing work against whom? Interatomic force. That is simply quoted in simple terms, the restoring force. Right? So work has to be done against this restoring force. So the work that is done by us or the load in elongating the wire by overcoming whom? The deforming force will get stored in the form of elastic potential energy in that wire. So if energy has to get stored, somebody has to do the work. Here, who is doing the work? Either we or the load. And that is doing the work against whom? Against the restoring force. Now read the definition, you can understand. The work done in stretching the wire, right? If you have to add more terms to it, the work done in stretching the wire by overcoming the restoring force is called that, which is stored in the material as elastic potential energy. Okay. Now our job is to derive an expression for it. So expression for elastic potential energy. Suppose a force F is applied on a wire of length, and its length increases by delta L. Initially, the internal restoring force in the wire is going to be 0, except initially when the wire is of length L, restoring force is 0. Why? Well, there is no deforming force, right? When the length is increased by delta L, right? The internal forces increase from where to where? The internal forces increase from the initial value of 0 to the value that you apply. That is F. Is that clear? Now, during this process, what is going to be the average internal force for you to create that increase of delta L? What is the average internal force? Initial value plus final value divided by 2. What is the initial value? Before you applied the load is the initial value, it is 0. After you applied the load, it was F. So 0 plus F by 2, which is going to be F by 2. That is going to be the average internal force acting for an increase of delta L length in the wire. Am I clear with this point? Wire initially here. You applied a force. The length is increasing by a factor of delta L, and this is L. When the wire was here, what was the force that you applied? 0. If the length increased, you applied a constant force of F. So what is the average force that you applied? 0 plus F divided by 2, which is going to be F by 2. Now, this force is the one which is doing the work on the object. Right? So, work done on the wire is by whom? Is by the average force multiplied with the displacement that the wire has experienced. How much is the displacement experienced by? From 0 to L, 0 to this point, it has experienced a displacement of delta L. So, work done in our F by 2 into delta L. But what did I tell you? This will get stored in the form of elastic potential energy. So U is equal to F by 2 into delta L. So what I can say is, if I have to give terms to it, can I say half into stretched force into increase in length, or average force into increase in length, right? So if I take the area of cross section to be A, then if I balance the equation, see what I'm going to do is U is equal to half into, can I write it as, if I will divide it with A and compensate it with A. So what else do I have? I have delta L divided by L into L. Because I have a delta L, I am dividing with L and compensating with L. So what are the two new parameters which we introduced? Area and length. So it is half into F by A into delta L by L into A into L. Correct? What is this? This is the potential energy. What is this A into L called as? It is called as the volume. So U divided by volume will be equal to half into, what is F by A called as? Stress. A by L is, delta L by L is called as. So half multiplied with stress into strain is going to give you the energy density. That's what I'm So energy density is given as half into stress into strain. So make a note of this. Here. Both are same. Yesterday I told you. External force applied is equal to the restoring force. There is a concept called as applications of elasticity. That part read it in the text. There is one page description applications of elasticity. It's theory, there is nothing much for me to explain. Okay, go through that. There might be a possibility of questions from there also. So NCRT answers are enough. Not a diploma, but major part I've covered everything. Right. So with this, we are done with this chapter. Is there any questions? Here. Okay. So I think we can wind up with this. I'm not able to speak. Okay. So next class I'll start fluid mechanics. Okay, tell me one thing, is there any topic that till the chapters that have been completed? Okay, so physics has both definitions and derivations. Right? So generally when a paper is tested, I hope those who are online are staying back. Nobody left, no? Very good. So generally when physics paper is given, then I'm talking about both, okay, well started. Yeah? Out of 70 marks, it will be somewhere around 55 to 53 marks of theory and 15 to 17 marks of problems. Okay. So till now, the pattern which we were following is I'll tell you this also honestly, 11th is slightly tougher compared to physics part. Okay. And yeah, so that is why I was concentrating more on problems part also. Right? I hope you guys could understand. Second is I have to help you in the exam point of view. It's not like I'm really teaching you problems. When it comes to exams, generally in your school, they are supposed to ask more of derivations. Did you feel that your question paper has more of derivations? Right. But since now MCQs have come, problems are also important. So what you need to do is you need to balance between both. Tell me honestly, is that happening? I'm just taking a review to understand what is the struggle you guys are doing. Can someone speak out? When you see the physics paper in your school, right? Generally, first exam you wrote 3 chapters maybe. Then it would have been 6. Now next 12. Yeah, 3 marks generally problems are fixed. Why is it happening? Like, why do you feel they are tough? Where are the problems being given from? Did you do an analysis after the test? Okay. Then that needs more of practice. But derivations part, are you struggling? That's easy. I understand that's the unfortunate thing. It's not like your 10th standard. So why I'm speaking all these things. I want you to slowly come out of the 10th standard. 10th you had direct problem. Even if you take concave convex mirror, the lens flat, all were direct. Sign convention and one formula could solve any problem. Am I right? But here, even there, I'm sure that none of you would have applied the logic of finding whether the answer you got is right or not. Tell me honestly, after you solve the problem, did any one of you use the logic of ray diagrams to connect and see whether your answer is right or not? Did you? One level. Answer on this minus the correct. I know this is what you do generally. So that's not how you are supposed to study. That's what I keep telling everyone. First thing that you need to do is what are the subjects? It's not only with physics, okay, any subject. Any subject that includes problems. So let's take MPC into consideration. Whenever you finish a paper, right, you should be sure whether your answer is right or not. Am I right? I just want to ask a question. Let's see. For me, only 12th questions are coming. Get together. Okay, so what you need to do is once you get the answer, right, most of you are not applying the logic and seeing whether the relations are directly proportional or inversely proportional. You got an answer, you leave it and you say, my job is done. That is where you need to correct yourself. Okay. And secondly, to answer your question, right, it's not about the quantity, it's about the quality. In the sense, what I generally do and what I suggest everyone is, you need not solve 10 problems. Or you need not solve 4 problems. You solve 1 problem in 4 methods. That's what I believe. The best chapter to experience it is trigonometry. Whenever a problem is given, what will you do? LHS, RHS, you will be happy with hence proof. RHS and try to bring back the question. That is the real challenge. How many of you have tried it? You have done it? Did you succeed? Yeah. So that's the right way to practice. Why I'm touching trigonometry again and again is that is the best chapter with logic. We have a lot of formulae. But at the same time, how those formulae will help you is to remember. How many of you have confusion? The sine 2 theta, 2 sine theta, cos theta, okay. Otherwise, have you ever tried it in terms of tan theta and tried to solve the same problem? No, right. 2 tan theta by 1 plus tan square theta plus sine 2 theta. Did you guys ever went out of your comfort zone and try to approach it in that way and try to get the answer? I'm getting among or one rest. No, right? Be honest. You didn't do that. That is why you're feeling it tough. That is the reason why the leap is actually making you struggle. If you do that right, trigonometry, let's say, for example, everybody is a math student. So you have, let's say, 25 formulae. I don't call them as formulae, I call them as equation because I have my technique of recollecting whenever I forget. It happens with me also. I teach trigonometry for ages, but I forget. I have a method to recollect. I have my techniques of doing. So people should crack it. Other you Secondly, when it comes to physics, right, you do a small analysis and see the chapter seems to be very big. But ultimately, if you take a paper and start writing all the mathematical equations that are there in it, right, it will not cross 7 or 8. And I'm saying that 7 or 8 is actually troubling you. Remembering 7 to 8 equations, is it troubling you? No, right? So even if you do 4 problems based on those 7 equations, you're going to solve 28 problems. So simple number, simple mathematics, right? Those 28 problems, at least if you're able to solve each problem in 2 methods, how many of them? What is the quality of it? Though you solved only 28 problems, but you have actually cracked 56 problems. That's what I'm saying. So you have to start thinking about it. And it's not about you getting the answer. You should have a logic of whether that answer is right or wrong. So in Puriya Bhasha, I'll explain. And I'm not sure if you guys remember whole of ray optics from your 10th standard. If I go into a mirror, okay, what mirror is this? So I say there is a mirror, a concave mirror of focal length 10 centimeter. An object is placed at 15 centimeter. V is equal to how much? Do it and tell me. I'll help you with the formula. So mirror formula 1 by V plus 1 by V plus 1 by V. It has only been 6 months since you wrote this. 1 by V plus 1 by U is 1 by F. பரவாயில்ல நான் இப்போ ஃபார்முலா சொல்றேன்ல 1 by V plus 1 by U is 1 by F. First of all, அந்த எக்ஸ்கியூஸ் இருக்கக்கூடாது. ஏன்னா if you're writing competitive exam, will you say that I learned this in 11th standard, so I forgot? Give me one more year time to take them. So 2 years are included. So first அதை வந்து கரெக்ட் பண்ணிக்கோங்க. அது ஏன் தெரியுமா you got that answer? First, you didn't work in a quality. You work only for the test. That should not happen. That is what I'm saying. Answer என்ன? 30 years. 1 by V plus 1 by U la enna pannanom? First thing you forgot is sign convention. Minus U pochange. Focal length of a concave mirror. Negative minus 10. So when you solve this, 1 by V is equal to 1 by 50 minus 1 by 10. And the answer is minus 5 by 50. Appa V odo. Correct. 150, no, minus 30. Okay, minus 30, I got a number. For example, you saw a previous thing, I made a mistake. I didn't write 150. I wrote 50. Answer on the result. What if you have left the answer like that? You will confidently come out and tell your friends, I got the answer. But I don't understand. Yeah. You made a mistake. What is it? I knew that the answer was wrong. I'll tell you how. That is when I started analyzing where I went wrong. If a minus 10 on the top, what does the theory tell us with respect to a concave mirror? The focal length is 10 meter. Where is the radius of curvature? 20 20 ray diagrams concept at least vega. So when you place the object at center of curvature, where will you get the image? That is the famous point. If you place it at center of curvature, you will get it at center of curvature itself. And again, my focal length is focal length on the 10. The previous mistake that I did fetched me the answer of 10 centimeter. Meaning another. Means if I place the object at focus, my answer told me that I'm getting the image also at focus. Is it not a blunder? Or I see, I place the 15 centimeters solum. So where is that 15 centimeter? It is between the focus and the center of curvature. So what did I get the answer as? I got 10 centimeter. When you place the object between the center of curvature and the focus, you should get somewhere else. You will get it beyond C. So beyond C now, is it greater than 20 means even before you solve the problem, you should be sure that your answer should be greater than 20. Another 31 the correct answer. Are you able to understand? This is what you are missing. You guys are concerned about formula and applying it and getting the answer. That is not science. When you start thinking this way, you will, first thing you will start enjoying the subject. Because it's like you're solving a case. Detective by feel. Yeah, I know this subject. Secondly, you will feel more confident about it. ஒரு நம்பர் பார்த்தோன்னே சொல்லலாம் இது நடக்காது logically this is very wrong. When that stage comes, do you think marks will be a big issue? In the question data, you are going to crack it. Only thing is take the data, plug it in the right equation, you're going to get the answer. I'm repeating it again. Practice trigonometry. At least, if possible, every day practice at least 3 problems. That is sharpen your brain. At least 3 problems. Take different books. Summa book cricket or very trigonometry page will open. Whatever question comes, solve it. Every day you will get a different perspective. Every day we get it. So what I'm suggesting is connect the subjects. I'm sticking to my subject connect. Chemistry not chemistry, physics not physics. Maths is not about math. I told you yesterday, math is only a tool to crack the derivations. For example, if I the derivation, had I not used average force, had I taken dx into consideration. Like when the course of the dx, then I should have applied work done is equal to ftx and I should have followed integration. So that is telling me that is just a tool out of them. But ultimately physics is physics only. Yeah, the ftx, who is telling? Is it math who is telling me? Why am I taking that ftx? Because that is a work done. That's what physics is telling me. But for me to crack that work done, I need the help of mathematics. Subject of don't see that is the first mistake you need to correct. For example, when I took the stress strain curve, had you known straight lines properly, I would have explained with more logic. Or graph on the analyze problem. I told you right that stress, that the graph initially is closer to stress. The logic is coming from physics, but who's helping us to draw the graph? It is mathematics. Functions is actually. And the y is equal to mx. How many of you know that how the equation has actually come? School of mathematics. How is it derived? It's one step. I don't want the answer. I want you to think what mistake you're doing. Even if this time you start correcting, you have 3 months, and trust me, annual exam you can do it with comfort. You will have nightmares. Nothing is there. You are unnecessarily complicating it. The systematic promise. Trust me. And reach out for doubts. When you're working, reach out for doubts. I'll help you. Whatever subject it is, reach out. I actually wanted to open my WhatsApp and show it to you of how many people actually 10th, 12th, the people literally torture us in a board exam. They get so many doubts, they take a screenshot and since that I'm not able to solve this problem. Within 4 to 5 hours, I solve it and send it back. Either me or whichever is the teacher for the descriptive subject. That is what we are trying to tell you again and again. Make use of the student support number. You Google and we are not going to scold you if you don't know an answer. Right? It is going to help us also. Let's say there are 5 people who are sending me a particular problem, saying that there is a particular problem which is of the common type. Next class, I'll at least help others. A class given, I'll explain. Okay, in the problem and the issue, the concept is not clear, I'll understand. புரியுதா? இதை விட்டுட்டு don't wait for our time or don't wait for the class hours. When you are enrolled here, you are enrolled for the course. இந்த கிளாஸ் வந்துட்டு போறது மட்டும் கிடையாது. You can make use of our services. Doubt இருந்தா கேளுங்க. Half of the time your parents talk on your behalf. அதுவே வந்து sometimes I plant. I don't want them to speak. Because you who study, you know the subject. You should ask, you should take your responsibility. புரியுதா நான் சொல்றது? Books எல்லாம் இருக்குல்ல. You have the books, right? You have the study materials and everything, right? That itself has a lot of practice paper. Did you guys go through it at least? There are NCERT solutions, additional exercise solutions. Solved examples. NCERT additional exercise. You have some practice questions, 1 mark question, 2 mark questions. What else is needed apart? Trust me, the director will get question. There is nothing in CBSE. There is nothing in CBSE. Competitive exam, I can understand. But CBSE, you people are putting yourself in struggle. For nothing. You are seeing it through a microscope, very vision. It's simple. Even boards, I say this is the word I use. There is nothing if you have the right logic in your. You need to think. I have seen people who have prepared only for 2 to 3 days in board, but they have scored 95%. Prepared, I'm not saying they open the book in the last minute. They have every logic in their hand. Again, then the question get along 11th, 12th, they will remember. The unfortunate thing with CBSE is 11th is not board exam, and you are not feeling the seriousness of it. 12th on the sudden seriousness. You will not. These 3 months, at least now, forget your 10th standard behavior, start working. Can I see some improvement? புரியுதா? அதே மாதிரி இது வரைக்கும் நடந்தது சார் இந்த டாபிக் புரியல அப்படின்னு சொன்னீங்கன்னா I will record and give it to you. You need not wait for my time. For example, you are going to school, morning 7 o'clock only you have time. Just drop me a message in the student number, student support number. Sir, I studied these chapters, projectile motion partition, and in the range maximum range, can you explain it? Happy to do it. I'll do it happy. But if you don't have that irritation, sir, math, I tried this problem. I tried to approach this particular concept. I'm not able to get the answer. Can you help me? Definitely. And if you help yourself, you're having so much of confusion. I can't keep counseling every class, but you don't want to see this. You have only 3 months. November is over, December, January. February, they will start. I don't know what urgency they have on planet. They will start 12 by March. Still, they will take next year March to complete. I'm telling you all the facts. If you want your life to be smooth, you help yourself. Make use of it. Seriya? So don't wait for our cause. Don't wait for help from my side. You reach up. Can I expect some change? Those who are online, can I expect some change from you guys? Or else tell me, I'll take a class of how to study also. Now, if that helps you, take it. How I used to prepare, I'll teach you. Or concept, everybody know how to analyze, how to save your time. These are all important. I understand you're not getting time, you have school work, 8 hours of school, I understand. But still, you can manage it. Mornings, you're free. Weekends, you're free. Except we are conducting exams, I'm not denying that fact, but not that every exam you are writing on weekends. No, there are some people who are coming on the other days and doing. What are you doing to your time? You're wasting your own time. I can understand the fact that you will have some aversion towards studies also. You will have some irritation towards studies because you're loaded with too much of information. But take breaks, take help. I can understand that also. What kind of psychological feeling you have. I've gone through it. Does it happen? You get irritated, right? At times you feel that's natural. It's not you who study, it's natural. You're not alone. Take some break, have some relaxation. Don't stress out yourself. Pace out a particular simpler. Breathe up. Any job in this planet, it is useful throughout your life. Because when you go to job, right, if you overdo things, you will burn out. You will lose interest towards it. But if you work as a team in the sense, you are helping yourself, you are approaching us for help. If we work mutually, right, it will be very easy. When we had a call, your dad told us that you have problem with trigonometric equations. Why did you approach us? You tell me. It's not only I know what is the data that I got, but you guys approach. I'll be the first person to help. I can understand. Wow, enter on the basis, sir, how do I solve it? Discuss. We'll try out different strategies. Work we'll keep figuring out new methods. Correct? Don't have a mental block of that. So, we are there only to help you to make use of the service and come up in life. So your excuses will not help you. On the time in the class attend COVID, what happened? Sudden lockdown open, you had your board exam. You will say that due to COVID, I didn't have interest in my online classes, so I didn't try it. Nobody will give you marks for the field. If they give you, or where your internal marks given for this reason, that is what it is. That is how world works. Correct? Nobody will help you. Nobody will be helping you. You have to help yourself. If you have a right mental, approach them. Even a time waste Now, I'm repeating this is I'm already working on a lot of content. If I can get a lot of inputs from your side, right, it will help me go in the right direction. And I can actually help you faster. So for example, a chapter படிக்கிறீங்க அந்த chapterல இந்த பிரச்சனை இருக்கு. If you bring it to me, right, I'll give you better explanation. So that I'll condense and give it to you in 10 minutes. You 10 minutes you will understand. I'll show you a lot of messages we are getting from 12th standard. We are conducting a test series. They approached me saying that, sir, these short videos are helping me. Can you help me with these topics? There are certain topics which we could not do because of time constraint. He asked me openly, sir, you can help on the Pananga. Now, one guy is literally chasing me. That's how you should be. No, I told Shreya Purida, can I expect something? Right? So I don't want any answers from your parents. I don't want any answer from them saying that my son did not understand, my daughter did not understand complex numbers, trigonometry, rotation mechanics. We both should work together. And your parents should feel they should not take that question because they don't know what is happening. It's your responsibility to give them comfort. Puridada, Hariharan? I'll talk to you. Okay? I'll see you there. Mithran, please reach out to me. Okay. We'll have a call.
Okay, sir.
Yeah. Solomon. It's there, I checked it. It's there. நான் போஸ்ட் பண்றேன். இல்லனா என்ன பண்ணுங்க subtopics ஃப்ரெஷா ரெக்கார்ட் பண்ணி that is faster for me. ஏன்னா அந்த வீடியோஸ் என்ன இருக்குன்னா here and there some noise இருக்கு. ஏன்னா அந்த கிளாஸ்ல வந்து வேற யாராவது டிஸ்கஸ் பண்ணிருப்பாங்க மாதிரி. அது வேற I condense and give it. சரியா? எனக்கு subtopics அனுப்பு. For example, thermal properties of matter, thermodynamics, fluid mechanics, the topics and புரியல சார். And a full chapter getting another time. But you say the subtopics, especially derivations part indicated, that's a distance. Either where subject doubts I get it done for you. Okay. That will help. Okay. Which one? Fully possible. Actually, I have another class at 7:10. I didn't see that. Can we have a discussion? If possible, we'll have a Zoom. So I'll give you the personal ID of the Zoom meet also. If you have doubt, now you can just take it. If you have an inform meeting, we'll have a discussion. So yeah, Mithun, I have a class. Mithun. Am I audible?
Yes, sir.
In a class, when I'm I'll have a discussion. Okay, can you have a call tomorrow?
Yeah, sure, sir.
Okay. Catherine and Narira, see what.